Good morning to everyone. Now we are going to see about the Unit 5 of a refrigeration and air conditioning system. Unit 5 is the cooling load calculations. In Unit 1 we see about the refrigeration cycle and refrigeration. Unit 2 is the refrigeration components, and Unit 3 is how we study about the properties of moisture air. And Unit 4 is the air conditioning system, how it is working, what are the components in the air conditioning system, what are the types of air conditioning system. And next one is the last unit of refrigeration air conditioning is the cooling load calculations. Cooling load calculation means when we design an air conditioning system, what we choose how much capacity of a refrigeration system is required, or how much capacity of air conditioning system is required. We need to calculate what are the loads on the cooling coil. The primary requirement of cooling or heating equipment is we need to calculate suppose it is a primary requirement is a cooling means we need to extract the heat from the moisture air. We need to extract the heat from the moisture air, and in different scenario we use a cold storage. We need to extract the moisture or heat from the cold storage products like meat or vegetables or different types of product. We need to extract the heat from our ice creams. We need to extract the heat from these products. For that we need to calculate how much quantity of we need to extract. Based on that we design a air conditioning system or cold storage refrigeration cycle. We need to design a refrigeration cycle. For that we see about what are the loads on the cooling coil or refrigeration system or air conditioning system. We need to calculate. The estimation of load involves the following variables. We calculate the cooling load, but cooling load also varies time to time based on the following external variables. What are the external variables affecting the cooling load calculations? The first one is the magnitude and direction of wind velocity. Suppose in outside atmosphere the wind velocities are high. Wind velocities are high means the heating on the wall of the room is reduced, because high wind velocity, more convection heat transfer. The heat from the walls are transferred from the atmospheric air. The load from the direct wall of the room is reduced. Next is the outside humidity and temperature. When the outside humidity are lower and temperatures are lower, when we mixing with the outside air to the room air, outside air with the room air, when the outside air temperature is around 26 degrees, take around for example 26 degrees Celsius and 50% RH relative humidity value, we no need to lowering the temperature, because it is also comfort conditions. In that time the temperature or cooling load of the refrigeration circuit is decreased. Next, nature of construction materials used. Nature of construction and materials used means in buildings. Suppose we take in room, what is the nature of material? It is a fly ash bricks or masonry brick or different types of bricks, hollow bricks. Maybe hollow bricks, the heat transfer from outside to the room is reduced. Next, orientation of openings, windows and doors. Orientation of opening in windows and doors are in the most of the in southern region or tropic of Cancer region or in our India, the most of the time the suns are facing towards the south. Suns are facing towards the south. When our room area or wall of the room, more larger area facing towards the south means more large amount of heat transferred to the room. It is on orientation. Suppose our room is not facing the south directions, means the heat transfer to the room is reduced. Cooling load is different from the south facing wall. Next, period of occupancy, number of persons, rooms, activities of persons. Maybe period of occupancy means suppose office building means 9 to 5 the people are occupying, maybe vary or fixed. The period of occupancy means some persons, take as a salon or beauty parlor. Some persons came with the timing. Some persons, for some period of time there is no persons, only the working people. In some period of time, more number of people are customers in the air conditioned space. Based on that, the air conditioning load are varying. Next is the activities of the person. Activities of the person means what is the activity going on inside the air conditioning space. Maybe it is a party hall. Party hall means activities are higher. Therefore, heat generation in the room is higher and moisture content also increased because of all of the human beings sweat. Make a more activity means sweating or more, and moisture content added to the room air is higher. For that condition, we need to remove the lowering the temperature and remove the moisture, excess moisture air. We need a more cooling power. Next is the cooling load estimate. The classification of cooling load. First one is the room load, which falls on the room directly. Room load means which falls on a room directly means it's a human being, persons occupying in the air conditioning space. The next is the walls. Next is the electrical equipments, electronics equipments, electrical equipments. It also has generating heat. It ultimately ultimately increasing the room air temperature. We need to cool the or extract the heat emitted from the all this room wall and electronic equipments human being. We also consider all of them, all of the heat requirement. Next is the total load which falls on the air conditioning apparatus. It is a room load. Total load means the atmospheric air comes into the building and mix with the returned air. It is also cooling load. It is also cooling load. We need to consider that. Next is the room sensible heat. Room sensible heat means first one is the solar and the transmission heat gain through the walls or roofs. It is all the sensible heat. It is increasing the temperature of the air conditioning space air. Due to the sun, the walls of the room are heated. The heat is transferred to the outside surface to the room air. Outside surface to the room air. It is a sensible heat due to the solar and the transmission heat gain through walls, roofs. Next is the glass. Directly sunlight passing through the glass. It directly heat the room air. Directly heat the room air because of the sunlight directly passes through the glass and directly heat the air conditioned space air. Next is the transmission gain through the partition walls, ceiling, floor. Next is infiltration. Infiltration means we frequently open the door and windows. The outside air mixing with the room air. It is an infiltration or some gaps in the doors and windows. In the gaps outside are mixed with the room air because in room the conditions are temperature is low and moisture content is low. It is a lower concentration range or low temperature range. In outside it is a higher temperature, higher humidity range. In that air is transferred to the higher temperature range to the lower temperature range. It is mixed with the room air and it start increasing the temperature of the room air. Next is the internal heat gain from people, power, light and appliances. The internal heat gain means people are using air conditioning space. They generate a heat. Basically, the human being or all living beings are generate a heat because of we use the energy by getting energy. Decomposing or digesting our hydrocarbon based food, automatically we generate a heat and energy. The heat are transferred to the room air, but it is additional to the room air. People and power, lights, appliances. Next, additional heat gain not accounted above. Safety factor. Safety factor means we calculate the total amount of heat, total amount of cooling load or heat enter to the room. We calculated, but all the condition, maximum possible condition is not possible. In some conditions, peak summer, some conditions, afternoon time or more amount of heat transfer from the wall to the room. But in actual condition, morning there is a less amount of heat transfer to the room, and atmospheric temperature are lower. And evening conditions same as the morning conditions. But these two conditions, the amount of heat transfer is lower. For that will be accounted as safety factor. Next is the latent heat load. Room latent heat load. Latent heat load means how much amount of moisture added to the room because of human being. They when they do activity, some Some activity means they make a sweating. The sweating water vapor water are added to the converted to the water vapor and added to the room atmosphere, room local environment. It also increases the moisture content in the room air. We need to reduce the moisture content or extract the moisture from the room air by the cooling coil. It is also one type of a cooling board. Or we use a different cooking appliances like pressure cooker. It is also adding the moisture to the room air. These are all the latent heat. Or some vegetables, we have a vegetables in the room. It is also adding the moisture content to the room.